With section 1.3, what did you talk about or do in your explorations with midpoint? What did you find out a midpoint was on Friday? It's directly between the two endpoints. So that means it's exactly in the middle, right? So midpoint meaning middle point. Okay, so if I have this segment here, AB, and I put a point here, let's just say R, that could be the midpoint, right? Okay. How they're going to distinguish that is with what we call tick marks. Okay. Those tick marks tell us that segment AR is exactly the same length as segment RB. Okay. As soon as the tick marks change, like if I did that, you think they're congruent anymore? No. Okay, they have to have the same number of tick marks to be congruent. And if these two segments are congruent, R obviously has to be directly in the middle, right? Thus making it the midpoint. Good. Okay. The other thing that goes along with a midpoint is what we call a segment bisector. A segment bisector does almost the same thing that a midpoint does, except it could be a line, ray, or segment that cuts this segment AB in half. Okay. Will the segment bisector always go through the midpoint? Yes, because the midpoint is in the middle, and to bisect or to cut something in half, you got to go directly through the middle, right? Okay, so the segment bisector will always go through the midpoint. Okay. Questions on midpoint or segment bisector? Okay, so let's take a look at an example here, similar to the one you have in your textbook, but it is different. So I have point P, Q, and T, and they give me this point M. They say that they're congruent, and our question is, what is the length of PQ when PM is 1.8 millimeters? Anybody think they can figure that out? 3.6. Okay. Jersey, how'd you get it? Okay, but there's only 1.8 up there once. So what do you know that about MQ? So I could label that as one. I know that's 1.8 also, right? Okay, so she took 1.8 plus 1.8, or 1.8 times 2, same thing, and got 3.6 millimeters. Okay, just pay attention to those tick marks. We're going to use those a ton. Okay, they're going to tell us things are the exact same length, and that's really going to help us out many times. Okay. Be careful. I noticed on some of our homework quizzes we missed points because of labels. Make sure you get them labeled. That's one thing I dislike about big ideas, is that they put the labels in for you. I wish they wouldn't do that, because labels are very important. There's a very big difference between millimeters or inches, or if you don't put anything, nobody knows what you're actually talking about. Okay, so be careful with that. Make sure you get the proper labels in there. Another example using midpoints and segment bisectors would be something like this. I have segment ABC. They tell me that they are AB is congruent to BC, which immediately tells you what about point B? Must be the midpoint. Okay, and then they tell me that this segment is 3x minus 4, and this one is 2x plus 1. They want to know what is the length of segment AB. Well, finding the length of segment AB could be really easy if we already knew what. We already knew what value? The x value. If we already knew the x value, that'd be really easy. I'd just plug it in, right? Okay, but I don't know x. How are we going to find x? You got to solve for x before you can do this. What did you say, Jason? Casey? Okay, so you're telling me, Casey, to set them equal to each other. Because you know they're the same length, right? Okay, so what I want you guys to do, and think about this as you go through any problems the rest of the year, into next year, any time really, if you can look at two things and say they are exactly the same, then you're telling me they're equal, right? If you can sit there and tell me that those are equal to each other, set them equal to each other. If you can tell me they're equal, set them equal to each other. That makes sense, right? See, that's what you just told me. I just wrote the letters in here and the numbers. Okay, now that I have this equation, should I be able to solve for x? Yeah. I take this 2x and move it over. 3x minus 2x is 1x. I take this 4 and I move it over. 1 plus 4 is 5. So x is 5. Okay. This is the next biggest, and online, this is the biggest mistake that I see. People type the answer in 5 and they get it wrong. I've already seen it once today. Somebody will do it again today. Hopefully it's not out of this class, but somebody will do it. Why is that wrong? Yeah, they don't care what x equals, do they? No, they want to know what AB is. So, since I know x is 5, I can plug that in. 3 times 5 is, minus 4 is, and there's no label, so it's just 11 units. Okay. Have you done that? Set two expressions equal to each other and solve for x? Many times, right? Okay, now we're just giving you a diagram that you have to pull that information from. Same idea that you've done for probably years, just in a different scenario. Okay. Questions on example 1 or 2? All right. Like I said, the beginning's easy. That was the beginning. The next stuff we're going to do is a little bit more difficult. Okay, we are going to take a look at a midpoint formula. The first part of this formula is probably going to be pretty easy. Now, if I have, so what we're trying to do, we're trying to find the midpoint between 2 points. Okay? If I have two numbers, for example, 3 and 7, even if it's on a number line, how do I find the exact middle? Without like a guess and check and just counting. What's that? Okay. I won't have coordinates on a number line though. How do I find the middle of two numbers? I add them both and divide by 2. So I find the average, right? Right? So 3 plus 7 is 10. Divided by 2 is 5. Is 5 the exact same distance from 3 as it is from 7? Yes. Okay. We're going to do the same thing here. Except with our midpoint, we're going to have coordinates. We're going to have x's and y's. So, to find our new x value, we're going to average the x's. That'll give me the x value that's exactly in between the original two x values. We're going to average the y's. That will give me the y value that is exactly between the two y's. So then I will get a new coordinate point. This will give me a new x value. This will give me a new y value. Okay. So all we're going to have to do, they're going to give us two coordinates. We're just going to plug them in for our x's and our y's. Okay. So the first example that goes along with this, example A, gives us a segment AB and they tell me that coordinate A is negative 8, 7 and coordinate B is 5, 1. They want us to find the midpoint. Okay. They want the midpoint. I have two coordinates. That's how you're going to figure out or understand that you need to use the midpoint formula. Okay. So to find the midpoint, which is always going to be labeled with a capital M, not a lowercase. Lowercase is slope. Capital M. I need to take one of my x's and add it to the other. So how would I write that? Negative 8 plus 5, and then do what to it? Divide it by 2. And then I need to go to my y's and do what? 7 plus 1 divided by 2. Negative 8 plus 5 is? Negative 3 over 2. Remember we talked Friday, just leave it just like that. That's perfect. And then on this other side, 7 plus 1 is, divided by 2 is 4. That's your midpoint. Okay, so a little bit different in your explorations. You had to take a ruler and and measure and guess. Hey, once you start getting strange fractions, you'll never be able to guess that right. So we will want to use the midpoint formula. Okay, that part was pretty easy, hopefully. All you got to do is plug your coordinates in. Okay? I will want you for the quiz tomorrow to memorize the midpoint formula. We'll do another formula that I'll give you, but this one should be pretty easy because all you have to do is average the x's and average the y's. Okay, so I want you to be able to memorize that for tomorrow. The second part, part B. In part B, they still give you a segment with a midpoint. The segment is PQ. They say that point's M. The difference is now they tell you that the midpoint is at 2, negative 3, and point P is at 4, 1. What makes this problem different than the last? I already know the midpoint. So I'm kind of solving it backwards, right? Okay. This tends to confuse people. Okay, so pay close attention, take good notes on this. There's another example in your book. So I'm trying to figure out the x and y values for Q. Correct? Okay. So thinking back to our midpoint formula, I actually already know the answer, right? The answer to our formula is 2, negative 3. That would be our capital M here, right? This is 2, negative 3. So let's plug that in. So I know that the far left side is 2, negative 3 equals, now I have to use my two endpoints and get this information. Okay, do I already know x1 down here? Yeah, it's 4. Do I know x2? No, it's just x divided by 2. Right? I'm just plugging in what I know. Do I know y1? It's 1 plus y over 2. Okay, so now I've plugged in everything I know. Somehow I got to come up with these values. Okay, well, going back to the last problem that we just did, when I took this part and simplified it, I got the x value, right? So when I take this part and simplify it, I should get 2, right? I should get the x value. So those two things should be equal to each other, right? Hey, what did I say a little bit ago? If you can tell me that two things are equal to each other, we should do what with them? Set them equal to each other. So 2 from here must equal 4 plus x over 2. Now we have one equation. Okay, it doesn't look so goofy like it does up above. We just have one equation. We just need to figure out how to solve that. How do I undo dividing by 2? Multiply by 2. 2 times 2 is 4 equals 4 plus x. Subtract your 4, x is equal to 0. So what does that mean if x equals 0? What did we just find? We found the x value of point Q, right? And we said it's 0. Now we have to go through that whole process again and find my y value. So I'm going to take my negative 3 and set it equal to 1 plus y over 2. Oops. And I'll give you guys 1 minute here to finish solving that out. Sophia, what'd you get? Negative 7, good. Did everybody else get negative 7? Okay, if you didn't, might want to check your negative signs here. Multiply by 2 on both sides, you get negative 6, and we got to subtract 1 more for negative 7. So that means my coordinate of my other endpoint Q was 0, negative 7. Is that significantly more difficult than if they didn't give you the midpoint? I think so. Okay, I think example A was easier. Okay, so make sure, a lot of people, the mistake they make is that they see 2 coordinates and they just automatically start solving it like this one. Okay, pay attention. If they tell you they gave you the midpoint already, this isn't going to work. Okay, just understand and pay close attention to what information they gave you. Okay, so that was the hard part for today. The next part, I don't believe is too difficult. So we're on to our last core concept, talking about distance formula. Now, most people have said that they've never seen this before. So I don't know if you used it a little bit last year or if you just haven't seen it at all. The distance formula, and I don't expect you to remember this or memorize this for tomorrow, but I will expect you to have it memorized by test time for chapter 1. Okay? But the distance formula, so the distance from point A to point B is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Have you guys seen that before? Okay, so I had some other students say that too, so maybe you just used it in one section last year or something. They said they've at least seen it, so. Okay. Now the next part I'm going to write down, I don't want you to write down. Okay. But let's think about this as a right triangle. Okay, so this is, let's say this is x, make sure I say this, do this right. This length here is the difference between x2 and x1. It's how far it is across. Okay, that would give me a distance, a length, right? If I took the 2 and I subtracted. This one's going to be y2 and y1. Okay, and then let's say this is our side AB that we're trying to solve for. Okay, what I'm trying to show you is this is just Pythagorean theorem. Okay, this side is A. This side can be B, and we're trying to solve for side C. Okay, so what we have here is Pythagorean theorem, because if I were to take this and square both sides, that would cancel, right? Square root and the squared, and then I'd have AB squared equals x2 minus x1 squared plus y2 minus y1 squared. Well, we said x2 minus x1 was a, so it would be a squared, plus we said this was b squared, and we said ab was c. Okay, so we could go through and we could alter a couple things, and it is just Pythagorean theorem. Okay, it's all the same thing. And we're going to do another thing later in the year that comes back, and it's Pythagorean theorem also, just in another form. Okay, so just understand that you have done things like this before. You've just thought about them in a different way. Okay. Now, the nice thing about this when I get there, there we go, is they're going to give you 2 coordinates. All you got to do is plug in for x and y. Okay, it's not going to be too crazy difficult. So they try to make it a little difficult in this problem they give us. Okay, I'm going to do an extra example here. They say that you live in an apartment and your school is 4 miles east, so 4 miles on the x-axis, and 1 mile south, so down 1 mile. Okay, that's where your school's at. Your friend lives from you 5 miles east to the right and 2 miles north. The question is, how far does your friend live from the school? So all you're trying to do is you're trying to find the length of the segment SF. You just have to plug your x's and your y's in. Okay? Start with your square root. Does it matter which one of these are your 2's or which one's your 1's? It doesn't. Just make sure if this is 2, if this is x2, that's y2. Okay, keep that in line. So let's go ahead and start with that. So I'm going to do x2 is 5 minus what? What's x1 then? 4. If this is x2, 4 must be x1. So 5 minus 4 squared plus, make sure you copy everything down right, y2 is 2 minus, careful, negative 1, okay, which actually turns into plus 1. And I still have my square root. 5 minus 4, 1 squared. 2 plus 1 squared, 9. So I actually end up with the square root of 10, right? I also talked on Friday, I want you to leave this like that unless they ask you to do what? Unless they say round to the nearest tenth or something like that. Okay, if they say round to the nearest tenth, you would end up with 3.2. Approximately, right? You'd be rounded. Most of the time on your word problems, you're going to want to round it. Okay? Because if you're talking an actual word problem, like a real life scenario, and I say, oh yeah, you have to go square root of 10 miles. You can have any idea what I'm talking about? No. Okay? So if you're doing a word problem, most of the time you're going to want to change it to a decimal. Okay? Hopefully I was right and that wasn't too difficult since all you had to do was substitute in. Okay? I do not expect you to memorize this formula for tomorrow, but I do expect you to know it by test time. Okay? Do you need to know the midpoint formula for tomorrow? Yes. Remember, that's just the averages of your x's and the averages of your y's. When you finish your assignment, I would highly suggest that you work on the practice quiz on page 28. Okay, you don't need to do all the problems. It's not an assignment. It's a recommendation. Okay, skip through the problems that you already know. If it says name 4 points and gives you a diagram, I'm going to guess that you can probably skip that problem, right? Okay, so only do the problems that you think you need extra practice on. When you get to class tomorrow, we'll take our quiz.